Alright, this is lesson 5.5 on linearization. Linearization is just finding the equation of a tangent line and using the tangent line instead of the original function to approximate. Because what happens is if you have, let's say you have a curve, and you draw a tangent line to that curve. Let's start over. Here. And let's just say I'm at 2. Just pretend. And say I want to approximate 2.1. Well, that's going to be really close to 2. So if you were to use this point on the tangent line instead of the point on the curve to figure out the y value, you're going to be really, really close. And that's all you're doing when you're using a tangent line to approximate. And why do we do that? Because it's easier to use a line than a curve. It's if you were working it out by hand. Alright, it says consider f of x equals the square root of x. We all know that f of 4 equals 2, but without a calculator, how can we find f of 4.1? So it says find the equation of the tangent line for f of x when x equals 4. Well, tangent line, y equals blank, x minus blank, plus blank. 4, 2, and then the slope, remember, is always just the derivative. So f prime of x would be 1/2 x to the negative 1/2. If we fill in 4, the negative moves it to the bottom, and it's the square root. So 1 over the square root of 4. So that's 1/2 times 1/2, which is 1/4. So there's my equation of my tangent line. And it says the tangent line you found is approximately the same as f of x centered at 4. Well, if you think about it, the square root graph looks like this at 1, 2, 3, 4. If we drew a tangent line, it would be about like that. It is gonna be exactly the same at 4. So at 4.1, it's just a little bit off right there. So all we would do is take 4.1 and fill it in where the x is. So it's 1/4 times 4.1 minus 4 plus 2. So that's a half. Caught that mistake pretty quickly. 1/4 times 0.1 plus 2. Yeah, I'm going to have to use my calculator for that. You get 2.025. Well, if we, I guess I could do it, 0.25 times 0.1 would be 0.025 plus 2 is 2.025. Yeah, I could do it by hand if I had to. Use a calculator to approximate f of 4.1. So if we do, well, f of x was the square root, so the square root of 4.1. Whoops. 4.1 is 2.02485. So 2.02485. So we approximated it. We said it was 2.025. How close is the approximation? You just subtract. So it's 0.00015. So that's the error here. We're actually going to skip the percentage change and differentiables. To find the error of the function, the error of the function is just saying from here to here, how far off are you on your y values? Well, if you use this value to approximate a point on the curve, well, you're going to have an error. It's not going to be exact. So to find the error, you just take what you get minus the approximation. It says use differentials. We're actually going to skip that. No, we're not. Yeah. When it says use differentials, it's just asking you to use the tangent line equation. So my formula, let's see if this makes sense, is the cube root of x, and my value is 29. Okay, this is going to get a little bit weird. We want to write an equation of the tangent line at some value that's close to 29 that will work out evenly in the cube root of x. Well, what's the cube root of something that will go into the cube root of x evenly? Cubes. Let's see, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Which one would be close? Well, 27. So we're going to use 27 to approximate 29. So I'm going to put 27 here. The cube root of 27 is going to be 3. And then I'm going to do the derivative. So 1/3 x to the negative 2/3. That's f prime of x. So f prime at 27 would be 1/3 times 27 to the negative 2/3. So that's 1/3 times 1/27 to the 2/3. I'm going to show my work. 1/3 times 1/, the cube root of 27 squared. So that's cube root of 27 is 3. Excuse me, I'm sorry. I hope I didn't sneeze into the thing. I apologize. So that's 1/27. And now, all we're going to do is we're going to stick the 29 in where the x is. So it's going to be 1/27 times 29, whoops, minus 27 plus 3. So 1/27 times 2 plus 3. So 2/27 plus 3. So how about 3 and 2 27s? Let's cheat. So let's see what that is, and then see what the error is. So I want to know the actual cube root of 29. Whoops. Control Enter. And then I want to do 3 and 2 27ths. 27ths. And now I'm going to subtract the 2. This is our approximation minus the actual. So our error is 0.001757, and our approximation here was bigger than the actual. So the error, it doesn't matter. It's just the difference is just 0.00176. So the error is 0.00176. It's easy. Approximate 1.002 to the 100th using linearization. We're going to do the same thing we just did. Our function is going to be x to the 100th, and we're going to get a number that's really close to 1.002, a nice even whole number. So how about let's use 1. We're going to write the equation of the tangent line at x equals 1 because 1's easy to figure out at that point. So y equals blank, x minus blank, plus blank, 1. If I fill 1 in, 1 to the 100th is still 1. That's why it's easy to figure out. And so our derivative is going to be 100x to the 99th. And if we fill in 1, we're going to get 100. And then I fill in 1.002. So that's 100 times 0.002 plus 1. If you multiply something by 100, you move your decimal 2 places, so it's 0.2 plus 1, so I get 1.2. So this is my approximation. And then to find out my actual, I would do 1.002 to the 100th. So I get 1.2216. So my actual minus my approximation. My actual is 1.2216. 116. Yeah. Minus 1.2. So I get, I don't know what that is. I can't subtract. Minus 1.2. 0.02116. Yeah, I should have been able to figure that out. 0.02. Wait, what am I doing? 0.02116. And blank page. Oh, same thing again. We're going to do this one exactly like we did example 4. It says approximate the cube. Example 4. Did we skip like, yeah, example 2 and 3. Where did they go? We went example 1, example 4. we're going to use this one's almost exactly the same. Try this one on your own. Yeah, and we'll look at it more. The approximate value of y equals the square root of 4 plus sine of x at x equals 0.12 obtained from the tangent to the graph at x equals 0 is, well, this tells you where to do your tangent line. So we're going to do y equals blank, x minus blank, plus blank, and you can tell this is a calculator question. Maybe. So it's x equals 0. If I fill this in for my y equals the square root of 4 plus sine of 0. Sine of 0 is 0. Yeah, because it's the y value, so it's the square root of 4. So that's 2. And my derivative, I'm going to rewrite this as 4 plus sine of x to the 1/2. So my derivative is 1/2 4 plus sine of x to the negative 1/2 chain rule times cosine of x. And we're going to fill in 0. So 1/2 4 plus sine of 0 to the negative 1/2 times cosine of 0. Sine of 0 is 0. So 1/2 times 4 to the negative 1/2. Cosine of 0 is 1. 4 to the negative 1/2 is 1 over the square root of 4, so that's 2, so that's 1/4. And then I fill in 0.12. So 1/4 times 0.12 minus 0 plus 2. Decimals, fractions, can't do it. 1/4, it's way too much. Way too much for me right now. 0.12 minus 0 plus 2. 2.03. So that ends up being B. Example 6, let f be a differentiable function such that f of 3 is 2 and f prime of 3 is 5. If the tangent line to the graph of f at 3 is used to find an approximation to a 0. Alright, first thing, write the equation of the tangent line. And if you want to, pause me and try it yourself. Try to do this one yourself and then see what you get. Pause. Unpause. This is, remember, f of x equals y, f prime of x equals m. So m is 5, y is 2, x is 3. So 3, 2, 5. So to approximate a 0, that means you find out where this thing equals 0. And you just solve it. 5x minus 15 plus 2 equals 0. 5x minus 13 equals 0. 5x equals 13. Divide by 5, divide by 5. X equals 2.6. The last one, is this the last one? No, there's 2 more. The function f is defined for x is greater than 0 with f of pi equals 1 and f prime of x equals sine of 1 over x. Use the line tangent to f at x equals pi, so a line tangent with f, y equals blank, x minus blank plus blank. Pi 1, it gave us that. F of x equals y. And then I need to find it gave me my derivative. F prime of x equals sine of 1 over pi. I feel like I need my calculator. Sine of 1 over pi. 0.313 if we go 3 decimal places. So 0.313. So use the line tangent to f at x equals pi to approximate the value of f of 4. So I'm going to fill in 4. Okay. So 0.313 times 4, oops, not 44, minus pi, plus 1. 1.2687 or 1.269. So 1.269, and now we have a choice. It says underestimates, overestimates. How do we figure out if something is an underestimate or an overestimate? I can't talk. Well, you basically got 2 situations. This one this one. If you approximated a point on the graph here, this is your approximation, this is your exact. This would be an underestimate. On this one, this is your approximation, and this is your exact. So this one would be an overestimate because it's higher. So if it's concave down, it's an overestimate. If it's concave up, it's an underestimate. So you have to figure out, how do you determine concavity? Well, second derivative. So we take the second derivative. So if f prime of x equals sine of 1 over x, or let's rewrite this as sine of x to the negative 1 to be easier. So this is my first derivative. Or I could do derivative at a point on my calculator. I don't even have to take it because this is a with calculator question. So if we do a derivative at a point at 4, or actually at pi. So I'm going to do menu, calculus, derivative at a point at pi, because I want to know if it's concave up or concave down, for sine of 1 over x. It's negative because the second derivative at pi is less than 0. It's concave down. So if it's concave down, it's going to be an overestimate, so it's B. And last one, example 8. It says the number of vehicles waiting to get past an accident scene is modeled by twice differentiable n of t, where t is measured in minutes for 0 to 8. The second derivative is greater than 0. I'm figuring that's probably going to be important in a minute. The table below gives selected values of the rate of change of n prime of t over the interval 0 to 8. The number of vehicles in line at t is 45. By using the tangent line approximation at t equals 4, which of the following is a possible value for the number of vehicles in line at t equals 4.5? Well, let's go ahead and write the equation of the tangent line. 4, 45. Now I need my derivative, which would be n prime of 4, which is 24, right there. And at t equals 4.5, so 24 times 4.5 minus 4 plus 45, calculator, 24 times, let's just go what? 2, what is that? 0.5 plus 45 is 57. Now, so 57 is obviously a choice, but it tells us that it's greater than 0, which means it's concave up, which says that my tangent line is here. So this is at 4. At 4.5, my tangent line says it's 57. This is 57. So what might it be? Could it be 59? Maybe. We don't know. Could it be 63? It's possible. So we could actually say all of them because of this information right here. So that was a tricky one, and this is the end of this video.